Russische kernonderzeeër Kursk.
Submarines sank to the seabed after.
В атомоходе «Курск» субмарина, на ней было более 100 моряков.
The salvage of the Kursk, a challenging operation awarded by Russian authorities to the worldwide heavy lifting and transport company Mamut after months of negotiations. Mamut's salvage plan differed from earlier operations in several decisive aspects, which promise a successful result before the October stormy season on the Barents Sea. Shortly after signing, Mamut subcontracted the bulk of the project to Mamut Smith, its joint venture with worldwide maritime service provider Smith International. They face an operation unique in the maritime world. The salvage plan generally looks as follows. The Kursk, 155 meters long, lies at a depth of 108 meters below sea level, 70 miles off the coast of Murmansk. Its heavily damaged nose sunk into the seabed clay. To yield a compact object that can be handled during the lifting operation, the damaged front section will be cut off by a specially designed robotic cutting wire. The salvage plan involves lifting the Kursk by means of 26 computer-controlled lifting units, all positioned on a barge. Once the barge is in place, 26 grippers, or lifting hooks, will be guided down into 26 pre-cut holes in the inner and outer hull. When correctly aligned, the gripper units will be hydraulically opened up and clamped under the frames of the inner hull, not unlike a toggle bolt. A bundle of 54 cables will be attached to each gripper. The cables are lifted by means of strand jacks that are situated on the deck of the barge. Each strand jack has a lifting capacity of 900 tons. Strand jacks lift hydraulically with a special gripping motion, not unlike climbing a rope hand over hand. They're often used for heavy lifts, but usually on land. During the lift, the force exerted on the attachment points on the Kursk needs to be constant. To maintain stability, the strand jacks will be fitted on top of a series of heave compensators that act like shock absorbers. They will allow the barge to move up and down while controlling the required tension on the strands. The lifting will be precisely controlled, centimeter by centimeter. The force on each bundle of cables can be set individually to minimize the tension on the hull of the Kursk. The animation made it all look feasible, but the reality was something different. There were only 5 months to handle the total job from preparation to actual lift. Preparations began in various places around the world. Altogether, 26 lifting units have to be constructed. Each lifting unit consists of a strand jack, a heave compensating system, an enormous cable reel, grippers, and gripper guides. Besides the strand jacks, every part of the lifting unit is specially designed and constructed. Hundreds of technicians work on all parts of the lifting system. Computer programmers are working overtime to get the lifting operation systems ready in time. The construction of the gigantic reels for the lifting cables is a major task on its own. Kilometers of cables will have to be rolled onto these reels to prevent an enormous wire spaghetti bowl on the deck of the Giant. A specially designed cutting wire will have to remove the nose of the Kursk. This cutting wire, consisting of a steel thread with specially processed buses, is first tested on an old sand dredge. Each part of the operation is tested extensively. Nothing can be left to chance. Part of the inner and outer hull of the submarine has been copied to determine whether the lifting plugs operate according to plan. A plug is lowered into the hole. It then opens and attaches itself to the frame of the submarine. A delegation of Russian engineers comes to Holland for the specific purpose of viewing this test. In the harbor of Rotterdam, the first equipment is prepared for departure to the Barents Sea. This involves two enormous suction anchors that are needed for the cutting operation. In due time, these anchors will be positioned in the seabed along the sides of the Kursk. It's mid-July, 2 months after signing of the Salvage contract, when the pontoon with the sawing equipment leaves the Rotterdam harbor. Meanwhile, engineers extensively calculate and recalculate all technical parts of the operation.
En dat is wat de lijn die de Russen hebben voorgesteld. Maar zoals deze tekening aangeeft, is dat een betere doorsnede.
While their complex work continues, the Giant 4 is transported to a dock in Amsterdam to be modified for the lifting operation. This 130-meter semi-submersible barge is normally used for the transportation of heavy loads that are normally placed on deck. For this particular job, the barge must be prepared to carry cargo below deck. Enormous saddles are mounted underneath the barge. The saddles are shaped to match the outer hull of the Kursk. Below the waterline, under the bow, a huge hole is cut for the sail of the Kursk. Saddles and hole are made to tighten the submarine firmly against the giant barge, which is necessary for a safe journey from the Barents Sea to the harbor of Murmansk. While work on the Giant continues, the barge with the cutting equipment arrives in the small Norwegian village of Kirkenes. Here, just a few miles from the Russian border, the final tests with the cutting system will take place. First, the salvage team needs to test the cutting system on an actual piece of metal similar to the material from which the Kursk has been constructed. At least, that's how it will work in theory. 2 cylinders are placed on top of the enormous suction anchors. The 2 cylinders, driven by gigantic power packs, have a suction pump that is able to reduce the pressure inside each cylinder, causing the anchors to work their way downwards into the seabed. After several days of testing, the team is satisfied with the results. The anchors are hung overboard before the 2-day journey to the Kursk site can begin. Here, in the sheltered bay of Kirkenes, this can be done easily. Doing this on the Barents Sea with its constant swell would be very dangerous. While the pontoon sets course for the Kursk, the finishing touch is put on the Giant in Amsterdam. As all parts need to be assembled on site, an assembly line is created on the quay immediately next to the Giant 4. First, all lifting cables are guided through the strand jacks. The next step is to guide them onto the reels. More than 200 kilometers of cables are controlled in this way. The cables are reeved, and the plugs that will need to be attached to the submarine have now been assembled and are being attached. It's August now. Time is pressing. The deck of the Giant is getting fuller all the time. As soon as a lifting platform is completed, it is hoisted onto the Giant 4 and installed over the holes that have been cut. In addition, the heave compensation system, consisting of 4 nitrogen-driven cylinders for each lifting platform, is installed. 28 containers with a total of 3,584 bottles of nitrogen are placed on deck. After 2 months of working nearly round the clock, the bare pontoon has been converted into a high-tech lifting bulwark, the likes of which the world has never seen. The signal for departure can be given. Even while work on the Giant is going on, an international team of divers is getting ready in Aberdeen, Scotland for departure. The diving support ship Mayo will function as a command ship during the operation. Without expert underwater work, the Kursk cannot be lifted. Before departure, the divers receive final instructions about what they can expect to encounter. They've been trained in particular to be alert for the potential danger of nuclear radiation. After all, the Kursk is a nuclear submarine and will have to be handled gently. Because of the depth of more than 100 meters, the divers must remain in saturation during the entire operation. This means they'll have to work and live for a maximum of 28 days under the same pressure that prevails at a depth of 100 meters. The first 12 divers prepare themselves for this heavy task. Once the door is closed, the ordeal of the divers begins. On July 22nd, the Kursk appears on the monitors of the diving ship. Almost a year after the fatal disaster, the first divers are standing on the hull of the submarine. The gigantic task of salvaging this 9,000-ton hulk, including the bodies of the victims, can begin. According to the lifting plan, 26 holes have to be cut in the inner and outer hull of the submarine. This operation will be carried out by the divers. They need to cut the holes using abrasive jet cutting. This involves the use of high-pressure water mixed with a special type of sand. The divers work round the clock so as to lose no time. After 28 days, the first international team of divers is relieved. The Russian Navy, constantly nearby with its vessels, coordinates the crew changes. The Mayo has a pressure tank aboard in which the divers live, sleep, and eat after their work on the Kursk. Each diver works 6 hours per day. While 3 divers are at work down below, the others can rest or eat. They fully depend on each other during this entire time. The work is proceeding smoothly. After several weeks, all holes have been cut and a start can be made with the removal of the nose. The Mayo has now been joined by the pontoon with the cutting equipment. First, the suction anchors are lowered. These anchors must be placed exactly in the right position next to the submarine. Slowly, the heavy equipment is lowered to a depth of 100 meters. Up above, on board of the Mayo, the positioning is being carefully monitored. Divers are working continuously to place the anchors properly. The work goes on around the clock. Once the anchors have been placed, the cutting wire can be lowered. The divers place the heavy wire across the nose of the Kursk, then attach it to the anchors on both sides. The wire has to be placed in the precise correct position. The separation of the heavily damaged nose and the hull is a must before the lifting work can be started. The nose might break during the lifting operation, causing instability that could generate unexpected forces on the lifting units. In theory, the 2 suction anchors suck themselves by vacuum into the seabed of the Barents Sea. At the same time, the cutting wire is moved forwards and backwards by means of the hydraulic cylinders. After an hour, the cutting wire is turned off to view the result thus far. When the underwater camera is lowered, the situation becomes clear. The wire is doing great work. It's lasted even longer than expected. The salvors continue with good hope. First priorities of the project team throughout the operation were the safety of all personnel on the scene and the protection of the marine environment. An independent radiological protection team of British and Belgian nuclear and weapons experts was on hand. Constant monitoring of all equipment and personnel at the scene during the entire operation confirmed no radiation leakage from the Kursk reactors. Every recorded level was well within the acceptable range for background radiation. When the nose is fully cut off at last, final preparations for lifting can start. Divers clear all debris from the holes. With special equipment, the remaining cables and pipes between the inner and outer hull are removed. These are the last preparations made on the hull of the Kursk to ensure safe and successful installation of the grippers. At this point, weather conditions are quite favorable for the salvors. In spite of the fact that the Giant and the Mayo experience high waves every so often, most of the time, the team members can continue their job. Slowly but surely, the lifting units are being prepared for the finale. Within a couple of days, it will be clear whether the lifting units that have been developed, constructed, and tested for months will also function in actual practice. The system is inspected for the umpteenth time. And the compensator system undergoes one more check. Tension is rising. Before the next phase can begin, the salvage team is faced with a solid setback. The wind is picking up. A storm is on the way. This means that the work has to be interrupted. In anticipation of the upcoming weather, the equipment is secured where possible to withstand heavy sea motion. Any damage or loss of equipment could have serious consequences for the entire operation. When everything has been secured, the team can do nothing but wait. The wind picks up to gale force. Several crew members nonetheless manage to go on deck to lash down some more pieces of equipment.
Gewoon wachten op het weer, hè? Dat is de uitdrukking voor WOW, waiting on weather.
The storm holds on for 24 hours, but in the morning, the sun breaks through and a rainbow appears on the horizon. The weather forecast looks favorable for the time being, and the crew begins immediately to undo the fastened equipment. 2 crawler cranes are used to unroll the 4 guide cables. Later on, the plugs will be lowered along these cables. They ensure that the plugs will not twist during their journey to a depth of 100 meters. The guide cables are attached to a ring in sets of 4. The divers then affix the rings to guiding cones which are installed on each hole. Doing so, the grippers can slide in easily. When correctly aligned, the gripper units will be hydraulically opened up and clamped under frames in the inner hull. Slowly but surely, the plugs inch their way down to be positioned in the holes. As the 0 hour approaches, the tension on board rises. As the first plugs are attached, the compensation system is also put into operation. The compensators with the strand jacks on top absorb the rocking of the Giant on the sea waves.
Hetzelfde geldt eigenlijk ook voor 4.6. 4.6 om 5 uur, oké.
Almost every gripper has a unique shape and has to be inserted at a different angle. The crew on deck and the divers below function as a smoothly operating team, and after 4 days, 13 plugs have been installed. 2 days later, the last of the 26 plugs has been lowered. For the divers, months of working around the clock finally came to an end. More than a year has gone by since the Kursk landed on the sea bottom. Now, shortly before the submarine is to be pulled loose, the salvage team pauses to reflect on the victims who are still on board. A commemoration plaque and a wreath are lowered onto the Kursk.
Ben je klaar voor? Divers, everything is ready, iedereen is standby. We can starting to lift.
The final phase has begun. The command is given to start the actual lifting process. The traction on the Kursk is gradually being raised.
Komt-ie?
We're getting nervous.
Als we losgekomen, prikkelt dan nog niet door.
Squeeze the load now and keep the COG of the total lift course at the same location, okay?
Yeah, so Roger, go for it.
Hij is los. Hij is los. Pas op, Jan. Blakhout, allemaal.
After 8 hours, success is already at hand. At 3:45 Moscow time during the night of October 8th, the Kursk comes loose from the seabed. Air bubbles evidence that the Kursk is moving. 9,000 tons of traction is needed to pull the hulk loose from the sea floor. It takes another 10 hours for the submarine to ascend the 100 meters that separate it from the bottom of the Giant. The heave compensating system works properly. At 3 o'clock in the afternoon, the Kursk is secured firmly against the bottom of the Giant. This calls for a little party on board. The most critical part of the entire operation, pulling the Kursk loose from the sea bottom, has been successfully completed. As soon as the Kursk hangs firmly underneath the Giant, the journey towards the harbor of Murmansk is begun. The tugboat Smidvai Singapore pulls the Giant Kursk combination towards the Russian harbor. The combination arrives in Murmansk after 2 days. Accompanied by the Peter the Great, a flagship of the Russian Navy, in the final phase of the operation, the submarine will be brought to a dry dock near Murmansk. Because the draft of the Giant 4 with the Kursk underneath is deeper than the floor of the dock, the Giant Kursk combination will have to be lifted. To achieve this remarkable lift, 2 massive submersible pontoons are to be built. The natural buoyancy will raise the pontoons together with the Giant Kursk combination and sail it into the floating dock. There, the lifting units will place the Kursk gently onto the supports. The Giant Kursk combination remains in the middle of the Bay of Murmansk, while the pontoons are slowly positioned on either side. The next step is to sink the enormous pontoons by flooding them with water. Slowly, the pontoons descend further into the water. Once they've sunk deep enough, they're moved underneath the Giant. As soon as the pontoons are underneath the Giant, they're pumped full of air. Slowly, they come upward. It has become cold in this northern part of Russia. After months of hard work, fatigue is starting to show its face here and there. When the pontoons are full of air, they have lifted the Giant Kursk combination more than 6 meters. The combination is thus far less deep into the water and will fit into the dock. Several tugboats push and pull the Giant slowly in the direction of the dock. The Russian Navy is meanwhile lending the salvors a helping hand. Dozens of sailors are now involved to assist in getting their lost comrades into the dry dock. Soon, the combination lies in the dock. The Kursk is back home. The Giant can leave the dock once again, but before that takes place, the salvage team honors the victims one last time.
Nagedachtenis, ons gevallen collega's, zeevarenden aan boord van de Kursk, vraag ik jullie even uw stilte na het gooien van deze krans.
Here ends a successful operation in which numerous innovations were needed to overcome the many challenges. Raising the Kursk is a story of technological ingenuity, perseverance, and courage in a fight against time and the elements by specialists from many countries.